Hello and welcome to another video by ES Repair. I am your host, Mr. Fix-It. In this video, what we're going to do here is we're going to do the initial setup of your computer's hardware. As you can see, we're at the logo screen that you see here. What we need to do now that everything's connected and everything's powered, now we need to do the BIOS setup configuration. There's not much that you need to do in BIOS. Most of it's set for defaults. We do need to go in there and check to make sure everything that we've plugged in and connected is working correctly. We also may need to make some minor changes. For instance, we did remove the battery from the motherboard during the installation process of the, while we built the computer. So what we're going to do now is we're going to have to go in there and change some settings. Now your BIOS may be different than what you see on the screen. This is just a basic idea to show you what to find and a basic description of what everything is. Now this one here, as you can see, this is the motherboard that we're going to be working with. This was part of the bare bones kit. So what we're going to do is go ahead and begin. Now you're going to see these messages up here that shows what keys to press to enter certain functions. Now your motherboard, chances are, is going to require to go into the BIOS. That's what we're going to do. So let me go ahead and let it resume. Now as you can see here, you're going to see a lot of message on your screen. This is part of the post test that the computer has to go through. As you can see here, everything it shows here is detected, but if you look towards the bottom down here, it's going to say that it needs to go into F1 or BIOS setup to do the configuration. This is in part because the battery was removed. So we basically just have to go in here and change some minor settings, and that's it. So you do what your screen says. If it says press delete or F1, press that key. In this case it says press F2. So, or F1. So I'm going to go ahead and press F1. F1 here will allow you to go into BIOS, as you see here on the screen. This is the first page that you'll see. If you notice up here at the top, you'll see there are other options. This is the first page. This is the important page. Now as you can see, the system time is wrong. So is the date. This is part because the battery was removed. So first thing we want to do is go ahead and set the date and time. Now you'll have the instructions on the right hand side. It shows you the keys that you press to go from one field to another. Now as you can see here, we got the time, we got the date set. Now what we have here is, on this motherboard specifically, we have a SATA 1 through SATA 6. Now remember, the motherboard that I installed had 6 SATA connectors. So what we're going to do here, as you can see here, my SanDisk, which is the first one, it shows that it's been detected. If you go ahead and open it, it's going to show you the device, the vendor or the manufacturer, the size of it, some other information as to how it's going to work with the system. Everything down here at the bottom shows auto, so don't worry about it, but it does show that the drive is being detected correctly. So press the escape key, we'll go back out. Now as you can see, SATA 2 also shows a hard drive. So we'll go ahead and enter it. Again, you'll see the device, some information. Everything should be pretty much matched up as the size of the hard drive. Again, down here in the bottom, you'll see where it says auto. Just leave it the way it is. Everything checks out, so we'll escape. Now we'll go down here. As you can see, these other 2, 3, and 4 are not detected, so there's nothing connected there. But I do have an ASUS DVD drive installed and plugged into SATA 5. So let's check it. As you can see here, the devices and the vendor, everything is connected. properly identified. As you can see here, everything's set for auto. Just leave it like it is. Now again, there's nothing on SATA 6, so this shows that I have 2 hard drives and I have an optical drive installed, and everything is detected. Now, what you'll go down here is SATA configuration. Now your motherboard may or may not have this. This is new technology. Now, as you can see on this page, this is a SATA configuration. You'll see the on-chip SATA channel. That means that the chip that's built into the motherboard, it's always going to be enabled because that's what we're going to use. Remember the motherboard when I did the disk drives, and I showed you that the hard drives were going to be connected to SATA 1 and SATA 2, but optical drive was set for SATA 5. This is why. With the new technology for SATA drives, especially the solid state drives, what I'm going to do here is I'm going to change this. Now the new technology is you're trying to tell the motherboard how the hard drives are configured. Now the hard drives by default are set to IDE protocols or ATA, and optical drives are set the same way. Now because I've only got 2 drives, I can set it for a RAID, but we'll go into RAID some other time in another video. But what we're going to do here, because of the new technology, I'm going to set this to AHCI. And what this does is it specially is designed for solid state drives. It allows the solid state drives to control the instructions that they receive. For instance, if they're getting multiple instructions to read or write, they can rearrange the order of those instructions that were sent from the system. It's similar to the NCQ that was found in traditional hard drives, to where the hard drives can reorder the instructions that they received based upon where the heads are located to help improve the efficiency of a drive and lessen wear and tear. This AHCI is the same thing for solid state drives. So I'm going to be sure to enable it because I have a solid state drive. If you do not have a solid state drive, do not enable the AHCI, because some hard drives will not work under this new technology. And the operating system may or may not use it. It was specifically designed for solid state drives. Now, as you can see, what happened was when I changed it, it also changed port 5 and 6. Now, because that the optical drive is on 5 or 6, depending on how you connected it, that has to go back to IDE, because if you do not, the operating system will not be able to see the optical drive. The optical drives do not use the new technology. So what we'll do is we'll just change it back to IDE. Now, as you can see now, I've got my solid state drive and my other hard drive set for AHCI. Now I've got my optical drive set for IDE. Now, you don't have to make any changes, but if you do have a solid state drive and your computer does support the AHCI protocol, then turn it on. Otherwise, leave it at IDE. Now, I'm going to go ahead and escape. Now you can go down here in the bottom. It says System Information. When you open that up, just gives you basic information as to the BIOS. Here it shows you the version that BIOS is, when it was created, the processor that's installed, and the speed, and how much memory is installed. Now, the processor you install should match. The amount of memory that you installed should match. So these two matches, you're good to go. If for some reason the two don't match, there may be a problem. We go ahead and escape. Now, as you can see, the first page is done. This is basically all you have to do in most cases. Next, let me show you the advanced options. Under here you have a little bit more control as to how your hardware behaves. Under here, this is for overclocking, which I won't go into right now. This is a dangerous thing to do, especially if you're not careful as to how you configure these. If the motherboard's not configured correctly, you may damage something, whether it's to burn the processor or your memory. Something may get damaged unless you know exactly what you're doing in this page. Now, what I've done here is I keep all these in automatic mode. This way the system determines what the computer needs to have. If it needs more throttle, it turns the throttle up. If it needs less throttle, it will turn it down, because the computer will go up to 4 gigahertz if it needs to. But if it's sitting there idle, why run at 4 gigahertz when it can run at 1.5 gigahertz while it's idling? So just leave these on automatic and the computer will do fine. But unless you're an enthusiast and you understand how overclocking works and the dangers involved, then you could tinker it. But right now I'm not going to go into this, because most people that I work with does not fool with overclocking. So just leave the way this is, and we'll just move on to the next one. CPU configuration, you can look at this. This gives you the basic information about the computer. You'll see the processor, what kind, what revision it is, how much cache it has built into it, the speed, which is the default speed that it produces. If it's able to change frequency, don't worry about that. That lets you know if it has the ability to change or if it don't. And down here in the bottom, this is how you can have it work, like the fan speeds, things like that. Just leave it the way it is. Next one that you'll see is a chipset. This one here tells you how the North Bridge will function. Most of this you don't have to worry about, because this is allowing it to how it manages the memory. ECC configuration. This is for those that's using the ECC memory, which is the error control. So if a memory sends data, then it's a polarity check. You can check to make sure that the data is being sent is correctly being sent. These are different than the standard memory modules, and we'll go into that some other time. But under normal circumstances you don't have to, because chances are you're not using that type of memory. They're much larger and they cost more to use, and in order to use them, the motherboard has to support them. Now the next one we have is the internal graphics. Depending on the motherboard that you have, like this one here that we're working with, does have an integrated graphics card. Some of them don't, so if your motherboard does have one in there, then that's fine. If it don't, you will have to put a graphics card in it, as you've seen in previous videos. Now this one here shows you the sequence that BIOS must take to find a graphics card, which one's primary. Now as you can see here, I want to change this to internal graphics, which is the one on the bottom. This means that it will look for the graphics card built in first and use that driver as a primary device. Or it could go to PCI Express or to the PCI bus, depending on what order I want. So as you can see here, I want my integrated graphics to be primary. Now the upper frame buffer, you really don't have to worry about this. This is an automatic feature because it determines how much memory to reserve from the system memory for the graphics. Depending on the motherboard, some integrated graphics do share system memory, but the better ones have their own dedicated excuse me, but the more dedicated graphics cards have their own memory, which is much faster than the system. Now if you have an integrated one like this one is, then you choose how much memory can be shared for the graphics processor. Now this one here can go up to 1 gigabyte, as you can see on the right hand side. So what I'm going to do here, depending on what it's going to be for, you can just leave it on auto, and the system can automatically adjust the amount of memory it needs for graphics based upon what you're using it for. Now for me, because of what it's going to be used for, I'm going to go ahead and just set it for 1 gigabyte. That's the maximum. Now, for down here for the frame buffer, you don't have to worry about this. You can leave it like it is if you want it. Not all motherboards have this. The frame buffer is the frame that is being used to process and store the video graphics for the processor, or for the graphics processor. Now what this will do, you can choose if you want it in the lower 4 gigabyte range, or if you want it in the upper 4 gigabyte range. This computer here has 8 gigabytes memory installed. So what I'm going to do here is I could say this, okay, well the program, the operating system and everything can use the lower 4. The graphics can use the upper 4. So what I'm going to do here, just leave it as it is, but you have to have at over 4 gigabytes for this to work. So let me go ahead and exit out of that. And that takes care of that one. Next we have the onboard device configuration. This is like the serial ports, the LPT ports, which is a parallel printer port. Some of the boards will have it, some do not. This one here happens to have one, but I don't use it. So I'm going to disable the COM port and the parallel port. This will save a lot of resources from the system that can be used for other things. HD audio controller, most motherboards have them built in, so just leave it enabled. This is the front panel select. What this one does is some motherboards have the ability to change the type of front connector that you have. It'll be the front connector in the front of the computer for like headphones, mics, things like that. You can choose if it's going to be high definition audio or if it's just going to be a standard left and right speaker. It just depends on how you want to set it up. I want to change this to standard, which is the AC97, which is a common protocol or codecs that's often used. Onboard LAN Controller. Now this is a different part. If you're going to use Ethernet, leave the LAN controller on. If you're going to use Wi-Fi, don't worry about it. Go ahead and disable the LAN. The onboard LAN boot ROM, leave it disabled. Your computer is not being used as a workstation and it doesn't get its boot up information from the network, so just leave it disabled. Down here, as you can see, this is a USB 3.0 controller. If it's disabled, go ahead and enable it. That makes sure that the hardware on the computer and the motherboard supports the 3.0, which this one does. If yours has 3.0, you want to make sure that it shows that it's enabled. If it's not, enable it. Going back to the main screen, we'll go down to the PCI plug and play. This is very important. because the BIOS wants to know if the operating system that you're installing is plug and play ready. Now, because I'm going to install Windows 7, of course, Windows is a plug and play operating system. Now, if you're going to install Linux or Unix or some other operating system, it may not be plug and play ready. If you're installing Windows, then go ahead and change this to yes. But before you install the operating system, check to make sure if it is plug and play ready or if it's not, so you can make this at the correct setting. So what I'm going to do here is I'm going to change this and put yes, because Windows 7 is a plug and play operating system. So let me go ahead and exit. Now you can go down here to the USB configuration. As you can see here, this shows you the model version of the USB configuration. This shows you how many devices there are. Right now it shows I got one mouse, and it shows I got 4 drives. That's because I have a card reader installed on the computer. Yours will probably look something similar to this. Now the USB functions, yes, we want them enabled. USB 2.0 controller, yes, we want that enabled. You have the legacy. Now this is for older versions of USB, like 1.1, which is pretty much phased out, but it won't hurt it if you leave it on auto, because BIOS will detect if anything is in USB 1.1. If it is, it will automatically make the appropriate adjustments. Now here you can change the mode that USB 2.0 is going to have. It's got 2 speeds. You have full speed, which is 12 billion bits per second, or you could choose high speed as it's selected now, and that goes up to 480 megabits per second. So by default you should be on high speed unless you have a lot of devices that only work on full speed. Now let me go ahead and select. Now we're done with this page on the advanced. We can go over to power. Now this really you don't have to worry about. This shows you the support that your computer can perform under the new power functions. Support mode, which is auto. This is the AHCI. This is the power interface. This what lets your computer to slow down, speed up, power cycle, or in this case sleep, which is a low power state. You also have the AHCI 2.0 support. If it's not enabled, go ahead and enable it. This is a new technology I was referring to earlier. The AHCI APIC support, just go ahead and enable it if your motherboard has it. This will help your solid state drive and your hardware and the operating system work more effectively. So you want to leave those 2 enabled. The APM configuration, this allows you to control what the computer does in the event that the power goes out. For instance, if you're in an area and the power just goes out, this tells the computer what to do when the power returns. Now you can tell it to come back on, or you can tell it to go into the last state that it was in, or you can just tell it to stay off once the power goes out. Power off is usually default. Now the rest of this you don't have to worry about. You can, however, if you want, use the keyboard to turn the computer on. Because the way the power supply and the motherboard is designed, there is power that's going through your computer. Now this one here particularly, you will notice that the numlock key and maybe a light that's on your card reader will stay on even though the computer's turned off. You may even see an indicator light on the motherboard that's still on to show that there is power. This is the 5 volt standby voltage. that I've shown you in earlier videos. That's what that is. Now if you want to, you can use it, but you don't have to. But the rest of it, you can just leave alone. The boot's a little different. This shows the order that BIOS will take to find an operating system. Now it can be in any order you want. By default, it goes to a removable device, such as a flash drive, or it'll go to your first hard drive, which is your boot drive, or you can have it go to your optical drive. So you have three choices as to what you can use to boot up your computer in a certain sequence. Now what I always do is I will change this to that, and there we go. So if the computer starts up and it can't find a hard drive, or can't find an operating system on the hard drive, for instance, let's say it corrupted, then the next thing it's going to look for is a CD-ROM drive. If I have my repair disk, or I have my emergency boot disk, some disk that I can use to boot up the computer, then it will boot up from the CD-ROM. Or if nothing happens and there's no disk in the drive, but I do have a flash drive that has a boot up program on it, then I can use the boot up program, but it has to be plugged into the computer to do so. This is the order that my computer will look for an operating system. First the hard drive, then go to the CD-ROM drive, and then finally to the flash drive. Now if it can't find anything, you're going to have an error that appears on the screen that your computer could not find an operating system or a boot device. So let me go ahead and back out of that. Now you come to tools. Now tools you don't really have to worry about. Now depending on the BIOS that you use, you may have software to flash the BIOS, so in case there's an update to BIOS, that's one of the first things that you want to do once you get on the internet, is check to see if there is an update to BIOS. It's a rare thing to happen, but on occasion BIOS is updated. But it doesn't hurt to check to see if there is an update, just in case that by the time the computer was built or the motherboard was built, there might have been a glitch and they had to fix it with a firmware update. So do be sure to check that once you're on the internet. Now down here is about the overclocking profiles. Again, I won't go into that. Now everything that you see here is set up. So now what I want to do is go to exit. Here you can exit and save your new changes if you made any changes. You can exit and discard the changes, so if you just want to exit out and not save changes, then it will. Or if you make a mistake, you want to start over, you can just discard the changes. Now if you have any problems with your computer or the BIOS, to where you have to come back in, it won't start up or something, or you're getting error messages when you start the computer, then you can have BIOS load the default settings. It comes in handy, especially if you're tinkering with the motherboard or the processor. This comes in handy. Now if you add new hardware, you may have to come in here and have it load defaults to reconfigure the new hardware. Now once everything is done, you made the necessary changes that we walked through, that I walked you through. Now we just go ahead and make exit and save changes. Now once this is done, your computer will restart. Now when it restarts, there's no operating system on your computer, so be sure to put the operating system disk in the drive for your optical drive before you begin. When the computer restarts, it's going to have to look for that operating system. Once it finds it, then it's going to find your operating system and then install it. And that's what we're going to do next, coming right up after this video. So go ahead and we're going to exit out of this and then stay tuned for the next video. I am your host, Mr. Fix-It. This has been a presentation by ES Repair. Coming up in the next video, we are going to begin installing the operating system and get your computer up and running. Well, this has been a presentation by ES Repair. Thank you for watching.